Welcome students to this screencast where we will be working with rational and irrational numbers. If you remember from the previous screencast, we talked about and we used a table from the Intermath Dictionary talking about rational and irrational numbers. Please go back and watch that if you have any questions regarding those two sets. We also explained the definition and gave some examples of rational numbers as well as irrational numbers. If you remember, a simple definition of irrational numbers is a number that is not rational. So now let's look at the following set of numbers. We have been instructed to place them in order from least to greatest, and so a number line may end up helping us. Also, identify each as either rational or irrational. So let's do this first, and then let's do the second where we put the numbers in order from least to greatest. Well, if you notice here we have 3 1/5. 5 times 3 is 15, plus 1 is 16, so 16 fifths. If we were to write that as an improper fraction, 16 and 5 both fall into the integers. So we have an integer divided by an integer where the denominator is not 0. That is a rational number. Looking at pi, we've already identified pi as irrational, so I'll just put IR for irrational. Square root of 12, well, if you think about it, 12 is not a perfect square. The square root of 12 will fall between 3 squared, the square root of 9, which is 3, and then also the square root of 16, which is 4. Therefore, 12 is also not an rational number, it's irrational. And then 3.5, notice this is a terminating decimal. So 3.5 is a rational number. So we've identified that we have two rational numbers, 3 1/5 and 3 5/10 here, or 3.5. And then we have two irrational numbers, pi and the square root of 12. So now let's put them in order from least to greatest. Right now we know that we have 3 1/5, and just for me personally, it's easier to think about them all as decimals. So 3 1/5, we can write that as 3.2, because 1/5, we can convert 1/5, multiply it by 2 over 2, and you get 2/10. So we have 3 2/10. Notice the place after the decimal is the tenths place. Pi written as a decimal is approximately 3.14159. We have to do some work with the square root of 12, but notice we already have 3.5 written as a decimal. Now square root of 12, I told you it's between 3 and 4. And notice 12 is a little closer, I think, to 9 than it is 16, but it's almost right in the middle. So let's start out with 3.5. 3.5 squared, will that get us close to 12? Notice 5 times 5, that's 25. 5 times 3 is 15, and 2 is 17. 3 times 5, that's 15. And notice here, we have 12.25. So the square root of 12 has got to be less than 3.5 because 3.5 squared gave us 12.5. But notice that means 3.5 is going to have to be the greatest number in that set. And in fact, I'm going to write it in a different color. All right. So now, notice it looks as if pi is going to be our smallest number, so I'm going to go ahead and put it as first in the set. Now we just need to know, what's 3.2 squared? If 3.2 squared is less than the square root of 12, then we know pi is definitely first when we're ordering these numbers from least to greatest, and then 3.2 will come next, and then the square root of 12 will come thereafter. So 3.2 times 3.2, 2 times 2 is 4. 2 times 3 is 6, 3 times 2 again is 6, and 3 times 3 is 9. When we add all this up, get 10.24. 10 and 24 hundredths is less than 12. Therefore, 3.2 is going to fall in line right after pi. And then the square root of 12 will come thereafter. So there you have it. We've identified these numbers as either rational or irrational, and we have also placed them in order from least to greatest.